What if I told you that the most breathtaking buildings on Earth almost didn't survive their own weight? Every mega project you've ever admired is a negotiation between beauty and physics, between ambition and the cold, hard laws of nature. And right now, engineers are pushing those negotiations further than ever before in human history. This is the story of how modern megaprojects are built, and why the line between architectural genius and catastrophic failure is thinner than you think. For most of human history, big had a ceiling. Stone, wood, brick. They could only carry so much load before they crumbled. Then we discovered steel and reinforced concrete, and suddenly the ceiling disappeared. But here's what most people don't realize. Making a building tall is the easy part. Making it stay standing, in wind, in earthquakes, under its own colossal weight, that's where engineering becomes an art form. Take wind. A 500-meter tower doesn't just have to hold itself up, it has to wrestle with hurricane-force gusts every single day of its existence. The Shanghai Tower solved this with a twist, literally. Its spiraling shape reduces wind load by 24% compared to a conventional rectangular design. That single design decision saved over $58 million in materials. Aesthetics and engineering aren't opposites. In the greatest mega projects ever built, they are the exact same decision. Consider the Palm Jumeirah. From street level, it's a luxury island. From 10,000 feet up, it's a masterpiece of geometric engineering. Every single one of those palm fronds had to be engineered to resist wave erosion, tidal shifts, and soil liquefaction. The nightmare scenario where the ground behaves like liquid during a tremor. The beauty you see above the waterline exists because of decades of invisible problem-solving happening beneath it. And then there's Millau, a bridge so tall its pylons pierce through the clouds. At its highest point, you are looking down at aircraft. The engineering challenge wasn't just height. It was temperature. Steel expands and contracts. On a structure this size, that movement is measured in meters, not millimeters. Every expansion joint had to be calculated with surgical precision, so engineers designed the deck to literally slide. 36,000 tons of steel and concrete, inching forward millimeter by millimeter, guided by GPS, across a valley 270 meters deep. This is what separates a mega project from just a big building. It requires solving problems that have never been solved before, with tools, materials, and ideas that didn't exist a generation ago. Today, architects don't just draw buildings, they simulate them. Digital twins, perfect virtual replicas, allow engineers to run thousands of structural failure scenarios before a single shovel hits the ground. They can watch a virtual earthquake shake a virtual tower. They can simulate 200-year storms battering a virtual bridge. And they fix every failure before it ever becomes real. The result? Buildings that don't just stand. Buildings that breathe, flex, and move. Designed to survive forces that would have been considered impossible to withstand just 50 years ago. And what's coming next makes all of this look like practice. The line in Saudi Arabia will house 9 million people in a single linear structure. No roads, no cars, a 170-kilometer city built vertically. If it works, it will be the most ambitious human construction project in history. If the engineering fails at any point along its length, the consequences are unimaginable. That's the reality of megaprojects. Every single one is a calculated bet against gravity, weather, time, and human error. And every single time one of them succeeds, it changes what we believe is possible. If you want to go deeper on how these structures actually get built from the ground up, the next video breaks down the construction phases of the world's tallest tower, step by step. Subscribe so you don't miss it.